from consciousness and after putting forward all the various debates and confusions about consciousness, which is still I feel if there is a consciousness, then what is it? But one thing we are more certain, whether there is consciousness or not, there is something called sleep, which is a definitive different state. At one point of time, it was thought that sleep is just about resting, restoring energy, till Klitman and other people found that just by recording the EEG, that it is a very, very active state. There is a major shift in change, that sleep from being considered as a passive, restorative, metabolic state, it is found to be an active state. That is one. The second, that sleep has components, sleep has stages which can be differentiated on the basis of EEG findings. So, there is a sleep which is a non-dreaming sleep called non-rapid eye movement sleep, and there is a part of sleep called rapid eye movement sleep. Third thing which was linked to it, that if you are awake for 16 hours, you sleep for 8 hours, what are these? Are these two different states of consciousness and mind, or are they connected? Do they have some combined functions? And the fourth question was that if we are surviving in time and space, and why are we having this different state? Is there a rhythm into it? Is there an oscillation? And that really seems to be the fact. Our body has biological rhythms. It has ultradian, which is basic rest activity, circadian, sleep wake, infradian, which is menstrual cycle, and circannual. But why have oscillations and rhythm? If you take this question to the brain oscillations, if you remember, I told you that if the whole brain is firing in an excitatory thing and there is no inhibition, then how will you differentiate change? Oscillations help you differentiate change, and that is because the basic purpose is information gathering. So, if change is natural, so these oscillations help us anticipate change. So, this is how you measure a biological rhythm, but there have been experiments which have entailed that a person was put in a shielded case, put down under the earth. It was padded so that the peak traffic time does not disrupt and let him know that it is the peak traffic time. Light fluctuation of the peak voltage peak consumer usage voltage fluctuation were not there, and he was left without a clock with a uniform light, everything else taken care of. So, the natural cycle of body and brain, the sleep wake cycle and all, turned out to be around 25 hours. So, 25 hours seems to be the biological rhythm, but because we have also created a contraption called clock. When we were talking about time, you really do not know what time you are talking about. Are you talking about a time which exists as a space time, or this clock? This clock is an artificial contraption which is a mode of convenience actually in fact. So, and these oscillations are entrained with nature. What in nature? So, what is the biggest entrainer of oscillation? The biggest entrainer of oscillations is sunlight. Right from photosynthesis in plants to the carbon structure forming to switching on and switching off. In fact, there is just above hypothalamus there is something called pineal gland. This pineal gland secretes something called melatonin, and melatonin, as the sleep time goes nearer, melatonin secretion increases. Over and above hypothalamus, this area, you see there is something called as a pacemaker. We know this because lesions of suprachiasmatic nucleus, they abolish free running rhythms. Activity correlates with circadian rhythms. Circadian is within 24 hours. Even if you isolate this and keep recording it, it continues to cycle. Once it cycles in the brain, it causes sleep wake, but in its own, it still cycles. And this is the most interesting fact, that if you take a suprachiasmatic nucleus from one person and impart to the other person, the donor's cycle will superimpose over the recipient cycle. That means nature has already genetically created one pacemaker. That means nature requires a master pacemaker. But why? Because lot of hormones like growth hormone, like cortisol, which is a stress hormone, your temperature regulation, all these move in oscillatory cycles within the sleep. Like in stage 3 and 4, growth hormone is secreted, which is important for kids. So this is just you can go through this at leisure. Various type of descriptions in. So what is sleep? We talked about consciousness, we don't know what is consciousness. What is sleep? But we don't know sleep either. That is the strange thing. In spite of all our knowledge, if you really ask somebody what is sleep, reduced motor activity, decreased response to stimulation, stereotype postures, relatively easy reversibility. This distinguishes it from coma, which is a part of illness, hibernation, which a lot of animals go, torpor and estivation. These are various stages. So, modern sleep research is part clinical, part research. EEG is the backbone of all this. And analysis should ensure that it is compatible with scientific evidence, is based on biological principles, applicable, easily used. Now, this is the stuff which has gone in to make what you call PSG. The full form is polysomnography. Why I am mentioning this? Because sleep is still is not a part of pure clinical labs or pure scientific labs. It's somewhere in between, because there is a lot of overlap in the whole thing. So, what is polysomnograph? It has EEG, electroencephalography. It has a EMG, electromyography. That means to measure the muscle activity. Electrooculogram, to catch the eye movement. It also requires ECG, respiratory effort. This is essentially, if you get this set of data, there are more than 50-60 disorders associated with sleep. So, you require all this. There is something called obstructive sleep apnea, where there is a problem in flow of oxygen. You require respiratory effort, nasal oral flow, blood oxygen saturation for that. There some people have what you call sudden body movements, called periodic leg movements, which is called PLMS. You require electrodes here to check that. So, modern definition, Nathaniel Kleitman, as I said, Serensky, Rakshev and Kales. So, what is all this is about? It is about this, that there is a REM sleep and there is a non-REM sleep. REM is rapid eye movement, and non-REM is non-rapid eye movement. It was found that there are, while a person is sleeping, there are phases of 20 minutes every 1.5 hour where the eyeballs move very fast. Later on, it was correlated that during this phase people dream. So, sleep was broadly divided into these two things, NREM and REM. That is the baseline. Initially, paper recording was done, and so all recording of EEG like this. So, it's the electroencephalogram, brain waves, electrooculogram, eye movements, electromyogram. This is the basic polysomnography. So, by EEG, what do? You check in the stages whether there is a variation in electrical activity throughout night. This you want to check to differentiate between the rapid eye movement and non-rapid eye movement. And this you check to see the muscle tone. Why? Because nature is smart. When you are dreaming, your mind is shut off from the external reality. That this group of neurons called locus ceruleus, where norepinephrine is a system of mind which gates attention, that is shut off, so that external stimulus does not enter. Because, and why it has done is the basis of one of the later theories also. If you act on your dream, the chances are you may hurt yourself. So your whole body is paralyzed except for breathing muscles and your eye muscles. Now, why eye muscles? Because even if lot of animals, when they sleep, they half sleep actually. Our jungle is a dangerous place. So you are half sleeping, your eyes are scanning the environment. Even with your eyes closed, it's scanning for any predator. So if a predator comes, as we have gone into more secure living, this scanning business has decreased, but rapid eye movement have been preserved. But at the same time, what you are also doing, you are also seeing dreams within. So when you normally look, you move. So the whole cinema is going on inside the head. Obviously, your eyes are not getting any stimulus from within. But when they were getting, so this was a evolutionary mechanism. So what happens in the stage? This is the type of stuff which you get. Awake EEG, fast in the range of 8 to 13 hertz alpha, slows down, muscle tone is still there. 2, the EEG further slows down with this sleep spindles appearing. Stage 3, 4 had gone into 4 to 7 hertz. Stage 4 further slowed down, 4 hertz. This is a normal physiological state where stage 4 appears. Otherwise, it doesn't appear. And then it changes to REM sleep where EEG becomes faster. See the muscle tone. See the muscle tone awake, decrease, decrease, decrease. It almost flattens. Eye movements have become more rhythmic. You can make it out. Now you can see this is the type of hypnogram. Awake EEG, stage 2. So your brain in awake stage, when it varies from 4 to 30 hertz, also keeps changing its rhythm. So in an 8-hour sleep of a normal person, what happens is that the first 90 minutes, you go down from awake to stage 1 to 2 to 3 to 4, right? First 90 minutes. And then the first REM appears. From this it goes to stage 3 to 2 REM sleep. As the night progresses, you can make it out here. The REM increases. That means the first 90-minute cycle, 20 minutes of REM, then the REM decreases, the NREM sleep decreases, then REM maybe increases to 30. So when you are getting to the morning hours, that is the maximum time of dreaming. So if you remember, most people wake up from dream. So this is a natural cycle which has happened. 90 minutes, 20 minutes, then stage 3, 4. And as night progresses, what decreases is the stage 3 and 4. That decreases. More of the sleep remains in stage 2. Okay, this is clinical, don't bother about it. This is how the whole polysomnograph appears. So Hans Berger was the man with the discovery of EEG, and he also showed that sleep and waking EEG differ. So what is the purpose of all this? See, this is again, you can see the EEG. An REM sleep stage represents successively deeper state with EEG showing increasing voltage, decreasing frequency. Relaxed awake EEG shows alpha waves, also beta. Drop in EEG voltage at sleep onset. Spindles and K complexes. These are oscillations which are happening. Remember the oscillations. REM sleep EEG resembles wake stage EEG, and REM EEG resembles that of stage 1 REM. So what is it actually? You forget the EEG part and the clinical part of it, which I have covered in one of the MOOC on psychiatry and overview. First, it was thought to be a simple quiescence period. Anyway, Freud gave his whole psychological theory of dream work. This was the first sleep lab. This is a very, very historical picture. We talked about architecture. So it is not about your sleep only. If you remember, we talked about in the first week about how the brain develops. So sleep is not something which comes after birth or whatever. It is inherent with development. A newborn infant sleeps more than 20 hours. Surprisingly, we do 80% of the sleep is REM sleep, that is a dream sleep. What is a newborn dreaming, we don't know. In the first year of life, because by the time they start speaking, they have forgotten everything. That is still one of the biggest research challenge, how to really get the content of the dream of the first year. As the brain myelination happens, as the brain network grows, it almost by the 10 year of life, it almost becomes like an adult pattern. But it's largely the first 3 years. So this, you see this is, if you just take it as REM, see so much. By the time it comes to 4 year, it is becoming like an adult pattern. Alpha waves normally become like mature people by the age of 10 years when myelination is complete. So this is so, sleep is so inherent right from birth. Otherwise, it wouldn't happen in the first year of life. So, and as you grow old, your sleep requirement also decreases. This is through the lifespan. Total daily sleep decreases. Neonate, these many hours. Infants, see this, children. As you become old age, you struggle with your sleep. Again, the same thing. The interesting thing is, as I said, we share a lot of awareness and this and that with animals. We also share this sleep business. All animals sleep. And this is an interesting thing. Birds have short NREM and REM sleep. Waterfowl can sleep while swimming. Dolphin, when it sleeps, one half of the brain sleeps, the other keeps awake. Reptiles have no REM. So, a smaller body size, each hemisphere takes turns sleeping. So, a lot of people will ask, why is sleep required or how much? Anything less than 4 and anything more than 10 hours is pathological. That creates problem. We can abstain from food long enough, but we cannot abstain from sleep. Your brain will crash. So possibly there must be an important function. Okay. Radio DJ sleep deprived for 260 hours became psychotic. Lost touch with reality. 264 hours in the supervision of sleep researchers. Now, some of them report ill effect for few hours. We do sleep deprivation experiments. We deprive people of sleep, but we recover most of the lost sleep. But it does not happen that if you have slept, you recover. When you recover, then there is a lot of differentiation. night 1 slow wave, by night 2 REM sleep. So, what happens is that there is a partial recovery of REM and NREM as you recover sleep. If you partially suppress, then obviously that phase will rebound. It happens with medication. If you take some of the benzodiazepines and suppress dream sleep, you get a deep sleep, but once you recover, then the dream sleep rebounds and you start seeing more dreams and all, very vivid, intense dreams. A lot of people complain that the whole night I haven't slept, I am dreaming more and more. So, extreme sleep deprivation will eventually cause death. There is an illness called fatal familial insomnia which leads to death, but the actual cause we don't know. So, why is sleep happening? Sleep may be adaptive. It forces us to be quiet at certain times of the day. It allows us to conserve energy. It allows us to avoid predators. Thermoregulation. As you sleep, the temperature falls. Morning time, your temperatures are the lowest. That means cortisol secretion is maximum here. 1. Growth hormones are maximally secreted in stage 3 and 4. That is very important for the growth. So, sleep alternating REM and slow wave cycle may prevent overcooling, because REM may be sending the activity like this. Slow wave sleep again cools down. But what is REM doing? Like this, growth hormone is only secreted during sleep, though not in kids under 4, not in adults over 60. So, what is REM doing? Does sleep promote learning? There is no good evidence. Sleep deprivation can have small effects on ability to learn, right? Slight increase in REM after difficult cognitive task. So, if you are using your brain too much, lot of complicated activity, your REM may go up actually. It happens with me, at least. You observe your sleep pattern. When I am thinking a lot, I am dreaming too much. But sleep is such a variable, some people do not sleep at all. While I was doing my sleep research, I almost used to sleep 4 hours in a day for 3 years and nothing happened. I don't know whether that has caused a ill effect now, but at that time, maybe I was younger at that time. So, no single theory of sleep, like no single theory of consciousness. So, we are still groping in dark. Although other functions like cardiology and other things, they have piggybacked on sleep research to find out. But the commonest theory which is most popular is about learning. It is about this theory which Hobson brought out. So, this is how it happens. The serotonin levels are high, they start falling, sleep triggers, 90 minutes later certain areas start secreting more acetylcholine in the form of pontogeniculoto-occipital waves found in cats, which send spikes, triggers of the dream sleep, right. Pontine lesions abolish REM related, this is acetylcholine. The reticular formation activates the forebrain from sleep. Now, this slow wave sleep to REM sleep, serotonin, acetylcholine. RAFE, which is a serotonin thing, 5-HT. So, lot of medication which induce sleep actually block this, the receptors of this. Why? You increase the serotonin level, activity level increases. You decrease the serotonin level, locus coeruleus promotes wakefulness, because as I said, this is the chemical which regulates attention. REM sleep, this shuts off, because you do not want frequent things coming in from outside. Now, because this shuts off and you do not want, this is, see how the brain looks at it for slices. If you give medication to activate this reticular formation to thalamus, you will keep activated. Lot of these drugs of abuse, which methylphenidate and amphetamines. So, what is the theory behind all this? So, forebrain areas the prefrontal cortex, the one which decides and all, gets activated while dreaming. Emotional centers get activated while dreaming. Because if you look at your dreams, you will find sometimes some dreams are very, very emotionally intensifying. You really get up panicking and you actually feel the emotion, but you are not acting on it. And dreams are so smart, they will also induct a lot of immediate needs. Like if you are feeling cold and you are sleeping, and if you are dreaming something else, somewhere along the dream, you will suddenly feel this need, or as if somebody is putting a blanket on you. It's actually nobody is putting a blanket. Your mind is telling you you need a blanket. Or if you want to urinate, suddenly a lot of people tell you that suddenly you feel like if you are urinating in your dreams. Now there is a whole racket of interpreting dreams, but that obviously has no value because people have correlated dreams and all. So what all activates in the dream? The occipital lobe, because that actually sends you the visual thing, the frontal lobe, because that gives you the meaning, and the emotional brain, which gives you the emotional content of it. So like REM off, 5-HT, I told you REM off, REM on, cholinergic system. So acetylcholine, now if you remember, I told you, is very important for memory. Damage to areas of acetylcholine, in dementia, the areas which actually get damaged are the areas where acetylcholine neurons are maximal. Acetylcholine goes up in REM, and it in fact triggers REM. Here comes in the clue. Is REM important for memory? And in fact, that is the theories which are the most popular. Again, thalamic reticular nucleus, as I told you. This is a type of imaging which shows if you go from waking to NREM sleep and NREM to REM sleep, this is a type of areas, but again we know these areas. Some area has to do something. So the theory which actually was brought out by Francis Crick and Christopher Koch, I think. Francis Crick was the person who discovered DNA. He shifted to neurophysiology. He says that REM sleep is about reverse learning. Whatever has gone into your head in the daytime or maybe in days before has to be processed, otherwise mind will get into overload. REM sleep serves the purpose of using whatever is important and consolidating it in the memory and rejecting the rest of the synapses. So synaptic formation for learning happens in the REM sleep. So that is the information processing thing. And these are type of stuff which goes into like executive function, logic planning. In dream you see loss of volition, logic, orientation, working memory. Dream emotionality, affective silence. Dreams consciousness. So there is a theory which has been brought out by Hobson, and that theory is called AIM. So the AIM theory says, which is an extension of the reverse learning, that whatever in the simplest, it's slightly complicated, whatever goes into your head is already there in the daytime. So the external input is stopped, the whole neural system is activated, the information is integrated, the synapses are modulated, the memory is formed, and rest of it which is not used is rejected. In that process, whatever is already being stored, already there, is activated, and that causes dream. It's like almost hallucination happening there in the brain, in which the present information is integrated, and that is why REM is very important for learning and memory, and it serves as a information processing. So this was briefly about sleep, and it requires a whole set of lectures on its own, because there are EEG parameters, like there is a imaging going on, and so our intention is not to talk about sleep so much, but sleep vis-a-vis consciousness, they formulate two states of mind which are very essential, and we don't know much about them, but brain probably knows much better and has its different state of electrical activity and synaptic formation during that time. So I'll end at that, and in the next lecture we will see where does it all stand in the current scenario and where does the research take us. Thank you.